0.019 S2 square. Now using this one, what you have to calculate? Capital S square. Okay, write your formula for capital S square. Capital S square is equal to capital S square is equal to n1 S1 square plus n2 S2 square divided by n1 plus n2 minus 2. That is the formula for capital S square. Find what is capital S square? So the inputting the data in the calculator is the important one, not doing properly. So open a bracket, again a bracket, 6 into 0.006 plus open a bracket, 6 into 0.019, close both the brackets, divided by 6 plus 6 minus 2. This is how you should input the data in the calculator. Find what is capital S square? 0.015. Same answer for everyone. Not here.
0.015.
0.015. Same answer. Yes. Every day at least half an hour, please practice with the calculator. Okay, but please spend time for a calculator operation. Capital S square 0.015. Listen. Okay, what should be your next step? T. Just calculate the statistic formula T. For that, all the data you have got. That is substitute and find what is the T value. What is the next step? Level of significance and degrees of freedom. What is the level of significance? Mention not given. Not given as 5%. Alpha is 0.05. What is the degrees of freedom?
N minus.
N1 plus N2 minus 2. It is an independent data, so degrees of freedom will be N1 plus N2 minus 2. That part I am giving it to you. You have to complete and come for your next class. That is on Monday. Okay, we are getting two problems. Only the last one I will ask you to solve it and done. Any doubt? Okay. So I discussed how to solve a single mean and difference of mean in small sample. Okay. So next we are going to discuss a similar concept using our standard deviation of variance. Okay. Okay, understood my area of this topic? Area for A1 is or no? Should we move on to the next one? So next we are going to discuss how to solve the problem based on single variance and difference of variance. Okay, to solve the problem based on single variance, we will be taking the help of our chi-square distribution. As well as for difference of variance, we will be making use of our F distribution. So for each one, I will get different distribution. Chi-square you are already familiar, yes or no? Where do you make use of chi-square? Already two tests you have completed more. Where you make use of chi-square? Chi-square everybody is doing, yeah? Thus we everybody defines the boys. Test for goodness of fit and independence of attributes. The same chi-square only will be applied for single variance. Only for difference of variance, we are going to make use of our F distribution. Procedures are same. Okay, H0, H1 assumption is also similar. Mean means we make use of the notation as mu. For variance, what is the notation? Sigma square. Okay, instead of assuming as mu1 equal to mu2, we are going to assume it as sigma 1 square is equal to sigma 2 square. Other procedures and everything are of variance. Test of significance for difference of variance. So here you are going to make use of our F distribution. So they know the test statistic is capital F equal to capital S1 square by capital S2 square or capital S2 square by capital S1 square. You write, I will tell you how to identify which one you have to choose. Where capital S1 square is equal to N1 S1 square by N1 minus 1. Capital S2 square is equal to N2 S2 square by N2 minus 1. Already I have given the discrete formula for capital S square in the previous list. So we want to make use of the discrete formula as capital S1 square will be equal to summation of x minus x bar the whole square by N1 minus 1. Another discrete formula is receiving similar. According to the given data, you can design your formula. So if you find difficult this one is make use of the formula for S1 square and S2 square like this and complete the problem. Anyway, you can get the S1 square and S2 square. Okay, right, next line. This statistic follows F distribution with mu equal to mu1 comma mu2 degrees of freedom. Here it is not single value, here it is an ordered pair value, degrees of freedom. mu1 comma mu2 degrees of freedom, where mu1 equal to n1 minus 1, mu2 equal to n2 minus 1. So generally we are writing like this now, but it will also change depending on the problem. Okay, make a very important note. Make a note. Always F is greater than 1. Always F is greater than 1. Very important point here to remember when you solve the F distribution. This F distribution one you are going to make use in your last unit now. So this point is very important one. Always the F ratio should be greater than 1. So what we have given the choices in the formula as two different categories. Okay, to get we are going to compare S1 square and S2 square. But the important condition is F should be greater than 1. If it should be greater than 1 means the bigger term should be come in the numerator. The lower term should come in the denominator. So either it can be S1 square by S2 square or it can be S2 square by S1 square. So you find S1 square and S2 square. Whichever is greater, put that in the numerator, the other one in the denominator. Okay. So if you are going to write the formula as S1 square by S2 square, this will be a degrees of freedom. Okay. If you are going to make use of the formula as S2 square by S1 square, then the degrees of freedom will be U2 comma U1. General way of remembering this, degrees of freedom will be numerator, denominator. First one should be the degrees of freedom for numerator, second one should be the degrees of freedom for denominator. What is the degrees of freedom? Number of samples minus 1. So either it can be n1 minus 1 or it can be n2 minus 1. Can you understand now? So this is a very important point now. The last unit, as I told you, is a 16-mark question. There you are going to make use of only this F distribution to solve. So what is the very important condition? F should be greater than 1. According to the F ratio, the degrees of freedom also will vary. The pattern of degrees of freedom should be numerator comma denominator. That is the point you should remember. Don't remember it as mu1 comma mu2. Numerator comma denominator. Just for writing purpose, we are writing like that. So clear? So you start with the problems. So right, first one. First problem. Pumpkin pumpkins. I am giving you all the sets of problems so that you will know the applications of our subject. Yes or no? This is why I am going to but can understand that we are applying all these concepts. This is not like any other math subject. Okay, whatever practically problems discussed, that is what you are discussing in your subject here. Okay, pumpkins were grown under two experimental conditions. Were grown under two experimental conditions. Two experimental conditions. Full stop. Two random samples of 11 and 9 pumpkins show the standard deviation of their weight as 0.8 and 0.5 respectively. 0.8 and 0.5 respectively. Assuming that the weight distribution or normal, test the hypothesis that the two variances are equal, against the alternative, that they are not, at 5% level. That they are not, at 5% level. 5% level. Read the data and tell me what is given, what are you able to understand? We are discussing about two different set of pumpkin samples. In one set, how many samples start it right. Given n1 equal to 11, n2 equal to 9. Then we are given s1 as 0.8, s2 as 0.5. s1 0.8, s2 as 0.5. Okay. So what is the next step you are trying now? H0 and H0. So write H0. We are asked to discuss about the variance. So sigma 1 square is equal to sigma 2 square. Always standard term. H1 will vary. What is H1 here? Sigma 1 square
Not equal.
not equal to sigma 2 square. Because they are asked to check whether there is a
Variance
difference or
between.
not. Okay, what type of test? Two tail. But here it doesn't matter for F distribution now. Whether it is two tail or one tail, they are going to be use of the same values. Okay, so for F distribution it doesn't matter, it is going to be two tail or one tail. Okay. So what is the next step? You have to write your formula. But to substitute the formula, what you need?
S1 square and capital S2
Capital
square.
S2 square. First calculate that one.
S1 and S2.
Capital S1 square equal to n1 S1 square by n1 minus 1. So n1 value is 11. What is S1 square now? 0.62. Okay, be careful here now. Some problems they will give the variance directly. In some problems they will give the standard deviation. Be careful which one is given. So into 0.8 square divided by 3. Don't make any mistake for this also. Give a unique answer.
0.704.
0.704.
704.
Everyone getting same answer? Yes? What is capital S2 square now? Same answer. Go. Proceed with S2 square. there will be two tables now. One table will be given for 5%, one table will be given for 1%. There will be two tables for your distribution.
Yes, ma'am.
Now one table. Where identify that one? The last two pages now. The last page is for 1%, previous page is for 5%. The table is clear now. Here in the column wise, it is a degrees of freedom for numerator. In the row wise, it is a degrees of freedom for denominator. What is the value here? 10. So in the column, choose 10. Row wise, you have to choose here 8. Match the value 10, 8. What is the answer? 3.35. They will take the same answer. You have to look into 5% table, not 1%. 3.35. So right. Table value is equal to 3.35. Don't put simply equal to ma. That is wrong. So table value F alpha equal to 3.35. Even if you don't put F alpha also doesn't matter, but you have to write table value. Now conclusion, compare. This is the calculated value. This is the table value. Accept or reject?
Accept.
Accept. Because the calculated value is yes. So we are going to accept it now. So write a conclusion. Since modulus of calculated value is less than modulus of calculated value, accept H norm. Accept H norm. So accept H norm means what is the conclusion? Difference is there or no difference?
No difference.
No difference, because you are assuming that sigma 1 square is equal to sigma 2 square. So right, hence there is no significant difference. Hence there is no significant difference between the true variances. Between the true variances. Any doubt now? Yes. So in some problems you will be given S1, S2 directly now. In some problems you will be given a discrete data. If you are given discrete data, what you have to do? You have to calculate small s1 square, small s2 square using the formula. In the previous problem you saw no, and then you have to substitute and find what is here f1. Okay.